All right, scrolling down, we've got a couple more refactors here. This first one, get story. Let's see. It's an async task method. We're returning Hacker News API service.get story. We're using async await. I could call configure await false here, and that would improve this method because I know I never need to return to the calling thread. But let's think about what's happening here. So let's say this method gets called by likely a background thread. So let's say thread 5 calls this method. So thread 5 enters get top story, and then thread 5 almost immediately hits this await keyword and returns back to the thread pool. Meanwhile, Hacker News API service.get story is running on a different background thread, let's say thread 7. And let's see here. So we add a configure await false. This means when thread 7 is done with get story, then it's going to, thanks to configure await false, grab any available thread in the thread pool. So let's say we jump back to thread 3, and thread 3 jumps back in to finish running this method, which is literally just to return the value. So we started on thread 5, we went to thread 7, and we finished on thread 3. That's 3 context switches just for this one line method. And that's just how async await works under the hood. Well, what we can do, because if I look at get story returns a type task of type story model, and get story, this method here, also returns a task of type story model. So what I can do is I can get rid of the async keyword, I can get rid of await, and I can actually just return this task. So now, when say thread 5 calls get story, thread 5 is going to enter this task, and it's immediately going to return this task. And if we scroll back up to where we call get story, so here is where we'll handle the thread switching. And technically, here is where we're finally awaiting that task. But what we've just done is we've essentially deferred the async await back up the chain. So instead of down here switching using 3 different threads just to make a one-line method call, we've now saved that thread switch and allowing that thread switch to happen just once up here when we initialize our get top story tasks. So our code's getting a little bit faster, a little bit more performant. Before moving on though, it is important to mention that when we return a task, it does affect our stack traces a little bit. .NET has a lot of logic built into it to handle how stack traces work when there's an exception thrown inside of an async task method. And by just returning the task, we do lose a little bit of that. So in our call stack, we might not see this get story method being called. We might just see this task being executed instead. So be aware of that. And some people don't like that. And I totally understand if you still want to use async await here, if you still want to say, use the async keyword and say return await. But in my experience with my apps that are in the App Store, I've never had a problem debugging this code or debugging code like this to figure out the problem, because usually that exception happens inside of this task, and that's where the problem lies. Rarely is that problem ever happening here. So just by returning the task, we save ourselves a context switch, improving performance, but be aware that the call stack might look a little different. But again, I've never had a problem with that in my experience. However, some people do still recommend using async await to preserve the call stacks in our stack traces. Okay, last refactor. What are we doing here? Well, it's another async task method, and this is where we get the top story IDs. And like I mentioned a minute ago, I'm going to cache data on my side because it seems silly to make an API call 2 seconds after we just made that same API call. Whereas we have that data, we can use that data. So with get top story IDs, I have this method that says, is the data recent? So has the data been, or has it been longer than an hour since we've fetched this data? And if it hasn't, if say it's only been 5 minutes since the user did a pull refresh, well, the Hacker News API doesn't update every 5 minutes. So we don't need to go back out to the API to get the new data because we already have that data. So for get top story IDs, we can just return the IDs from our top story collection. Makes a lot of sense. And if that data is not recent, so maybe that data doesn't exist, or maybe it's been 2 hours since the user did a pull to refresh, well, then we'll go out to the Hacker News API and we'll get those top stories. Now, look at this code. It looks pretty good. I mean, again, we could add in a configure await false here since we know we don't need to return to the calling thread. And we don't want to return to the UI thread, certainly. But if I look at this again, get top story IDs returns a type of task of type frozen set of type long. And get top story IDs, this method also returns a task of frozen set of long. And the only place we're using the await keyword is here in the return method. So just like above, what we can do is we can get rid of the await. We can get rid of async. And we have to do a little extra to say task from result and pass this in here. There we go. And boom, red squiggles are gone. And so now we're just going to return the task or the completed task with the result if we've already cached that data. But this is actually a trick question, or a trick answer rather, because this is bad. This is bad because we're actually inside of a try catch block. And by returning this task, we're going to exit this try catch block immediately. Whereas instead, I wanted to catch that exception and log it in trace write line so that my crash reporting tools are aware of it. But what's happening now is we're going to enter this method. We're going to hit return, and whoever called this method is going to get this task. And because we've returned, we've left this method, meaning we've left this try catch block. So if get top story IDs, if this API request fails, well, we're no longer going to catch it here inside of our try catch block because we've already exited the method. So trick question, trick example, we actually want to keep async await here, even though we're returning the same signature. And even though the only place we're using the await keyword is in the return statement, because this await keyword tells this task, get top story IDs, to finish and stay inside of the try catch block until it's finished, so that if this task does throw an exception, the await keyword will rethrow that exception to us, which we'll catch here and we'll be able to log. So, bit of a trick for this. This refactor is actually good. We don't want to return the task, but there is a performance improvement I see here, and that is that we can leverage value task. If you've never heard of value task, it's similar to task, but task is a reference type, whereas value task is a value type. It's a read-only struct. And this means that value task will get initialized onto the stack because it's a value type, whereas task gets initialized into the heap because it's a reference type. And if you remember from your studies around stacks and heaps, adding a new value to a stack is O of 1. It's basically immediate. We just push it out of the top of the stack. Whereas when we add a new value to a heap, that takes a bit of extra time because the heap has to get indexed. So it's going to generate a key, and that takes more time than just pushing out of the stack. So here we can leverage value task. And the reason we can leverage value task, and the reason we want to leverage value task, is because the hot path in this method is right here, and the hot path doesn't use the await keyword. So if we run this code the first time, and we just launched the app, the data is not going to be recent. So we're going to have to come down here and use the await keyword. But the second time we run this method, if the user does a pull to refresh again, we don't use the await keyword. And the third time this method runs, we don't use the await keyword. The fourth time. So 99 times out of 100, as long as it's been within an hour, we're not going to use the await keyword in this method. And anytime you have a method where the hot path, this path, for this method, the hot path does not use the await keyword, instead of returning task, we can return a value task and get a small performance improvement. Now, value tasks are not exactly the same as task. They are slightly different. One example is never reuse a value task. With tasks, we can absolutely reuse them. We can say, for example, var minimum refresh time task up here, we can wait for it to finish. Then we could reinitialize this as another task.delay. And then we can await it again. And this is very valid code. We can also pass around tasks. So we can, instead of awaiting tasks immediately, we can pass them around to other methods. But we don't want to do that with value tasks. Value tasks basically use it as a return value and consume it just by awaiting it. That's the best advice I can give you. There are more documentation on the subtle differences between value tasks, but if you only use value tasks for returning values and you only await value tasks when you call methods that return them, you'll be fine. The only time I recommend using value tasks is when the hot path of your method does not use the await keyword. So it's a bit of a niche tool, but as a library creator myself, I find myself using this a lot because there's many times where I write code that maybe runs on different platforms. For example, this Maui app runs on iOS, Android, Windows, Mac OS, and maybe the API on iOS requires async await, but the API on Android doesn't. I'll use value tasks in my apps and my libraries in those cases as well, because why would I want to push a task onto the heap and bear that performance hit when I never have to use it in the first place? So if you're not using the await keyword in the hot path of your method, use a value task. Be sure not to reuse it when you call, in this case, get top story IDs. Just use the await keyword and you'll be safe.